Section 6.2 talks about real applications and normal distribution. So, the z-score is used with our normal distribution. A z-score is the number of standard deviations that a given x is above or below the mean. If you recall, we talked about that too many times by now. Now, the calculator is going to give us an option, and I'm going to show you both options of how to do this. The formula, given a score, to find z, you take the score minus the average divided by standard deviation if this is the sample. Oh, it's right there. And for the population, you take the score minus the average divided by standard deviation. We always round the z-scores to 2 decimal places. Now, here's an example. Consider your height in inches. Calculate the standardized value z-score. So they want us to find the z-score for your height, given that in the United States, the average height for women is 63. So we have an average of 63.7 inches with a standard deviation of 2.7 inches. We're using population because this is in the United States. As for men, the average height is 69.1 inches with a standard deviation of 2.9 inches. Would you be considered tall for your gender? Well, let's see. My height so you're gonna measure your own height. Okay, get it again, the thin one. My own height, I am 6 feet high. 6 feet tall, I'm sorry. I am 6 feet tall, which means I am 6 times 12 inches. That is 72 inches tall. That's my height. That's X. That's me. I have 2 options. So would you be considered tall for your gender? The average is 69.1. I am with a standard deviation of 2.9. So no, I'm not. How would you be considered tall for your gender? Well, let's see. Since I'm a male, I'm going to assume the average, which is the center, is 69.1. If I add 2.9, and I don't have to do that by hand, you guys, we do everything on a calculator. We have it, use it. 69.1 plus 2.9, 72. And if I add another standard deviation, another 2.9, that would be 74.9, and another standard deviation, so plus another 2.9, that's right, and another 2.9, 77.8 inches. So remember how that goes? Within 1 standard deviation, within 2 standard deviation, we assume those are usual. Anything above 2 standard deviation or below 2 standard deviations is considered unusual. I'm right there. I have a height of, oh, not even. Oh yeah, I am. Sorry, yeah. So I'm within 1 standard deviation. My height is usual. I could do this too. I could say, find the z, instead of me doing all of this work. Do you notice what I had to do to figure out that I am 1 standard deviation above the mean? I could have just said, you know what, take the score minus the average divided by standard deviation. The z for the height would be 72 minus 69.1 divided by 2.9. And this is going to tell me how many standard deviations am I above or below the mean. So parentheses, don't forget, you're being graded on using the calculator properly, so make sure you use this calculator as you're doing your homework. 1. So this is telling me that I am, since it's positive, 1 standard deviations above the mean. Remember, for you to be unusual, you must be 2 above or 2 below, either unusually high or unusually low. It says, what is the probability that someone of your gender is taller than you? what's the probability that someone from my gender is taller than me? What does that mean? They're over 75. Or, isn't that the same as saying probability that z is greater than 1? So what's the difference between those? This, what it did, it makes the average being 0 and moves in standard deviations. Instead of having 69, 72, 74.9, it's just making data 0, data 1, data 2, data 3. That's simple. And the calculator, our calculator, allows us to do both, and I want to do both. So if I want to stick with x, that's not a problem. If I go for my calculator, x is greater than 72. Aren't you looking at this area? So let me use purple. X is greater than 72. Aren't you looking for that area? So I could say this is going to be distribution, if you remember from the last homework, and we're going to go for what? Normal CDF. We never use a normal PDF. Normal CDF. It's asking, what's the lower bound? 72. We're going by x. What's the upper bound? 1e to the 99. What is the average? The average in this case is 69.1. What's the standard deviation? 2.9. Tell me what that probability is, and here it is. So let me put that in and elaborate on what we just found. So here, we figured that the probability of finding somebody that's taller than me, in this case, is 15.87%. Now, I could do probability that z is greater than 1. What's the difference? The difference is, this is a standard normal. Z is greater than 1. When I go to my distribution, I go for my normal CDF. What's the lower bound? A 1. What's the upper bound? E to the 9. What's the average? 0, because that's standard normal. Standard deviation is 1. And guess what? For sure we're going to get the same answer every time. So how do you do this? This calculator allows you to do that. Normally, we must convert to z to be able to figure things out. Not using this calculator. That's one of the beauty of this. And hopefully we all checked it out from the library like you said you did. And there it is. 15.87% chance of that happening. Now, I'm going to do every problem using both. Using either the x or the z. You only have to choose one. Stick with it. The calculator allows for these options. I'm going to run down to the third example, then come back to the second example. It says in the third example, the lifespan of a brand of automobile tires are normally distributed. That means it fits under the normal distribution or the z distribution, with a mean of 35,000 miles and a standard deviation of 2,250 miles. The lifespan of a randomly selected tire is 34,000. If you pick the tire, you'll find that they survive for 34,000. Find the z-score for this tire. So first they're asking specifically z, x minus the average divided by standard deviation. The z-score is 34,000 minus 35,000 divided by 2,250. And this tells me how many standard deviations is this below the mean. I'll get to my calculator, parentheses, 34,000 minus 35,000. Of course that's 1,000, but let the calculator do the job. That is negative 0.44. Negative 0.44. That's within one standard deviation. That's not varying by much. Then it says, find the z. Can you find the probability that a randomly selected automobile tire has a lifespan less than probability that a tire has less than 34,000 miles? Well, you have two options. Since we found Z, we could say that's also the same as finding the probability that Z is less than negative 0.44. Now, what's the difference between those? Here you're saying this is 35,000, and I'm looking for this area. Here, you're saying the average is 0, and this is negative 0.44, and I want the area to the left. The same deal. Well, let's do both. If I decided to use the green, then I'm going to say, let's go by second distribution. We want both cases the normal CDF. What's the lower end? Negative 1, and if you remember, E, it's right there to the 99 because that runs to the left. What's the upper bound? I'm going to go by 34,000. In this case, I can't say the average 0 because I'm using the green. I'm using X. What's the average? 35,000. What's the standard deviation? 2,250. Figure out that probability. That's my answer. 32.84%. About 33%. So this right here there's my answer. And if I want to go by the z-score, well, the same deal. What's the difference? Distribution. I'm going to go for my normal CDF. The lower end is such and such, but the upper end, now I'm going to say it's negative 0.44. What am I going after? Well, here, the average is 0 and the standard deviation is 1. And what's the answer? It turns out to be the same. 32.996, so roughly 33%. Now, you will notice there is a slight difference because of the rounding. When we round a z-score, we only carry 2 decimals. So they are, but if you round them to the nearest percent, they're always the same, and either of those will be accepted on a test. Either answer is fine. So this is using the z-score, this is using the original. If I didn't ask me for the z-score, I would have just used the green. Not that it matters. Now, the average for a student exam, the average for the statistics exam was 75. The average was 75. And the standard deviation was 8. So this is one test. Andrew was told by the instructor that he scored 1.5 standard deviations below the mean. Andrew scored 1.5 standard deviations below the mean. And the scores are normally distributed. What was Andrew's score? Well, this is what I know. Z equal X minus the average divided by the standard deviation. Z is negative 1.5. The score is what I'm looking for. The average is 75, and we have to solve these equations every now and then. The simple algebra, you cross multiply, you get X minus 75 equal negative 1.5 times 8. Well, negative 1.5 times 8. That's negative 12. And if you add 75 to both sides, guess what? Plus 75. His score was 63. So they say, what was Andrew's exam score? Andrew's exam score Andrew scored 63 on the test. There it is.